So now today's class we are going to see the next concept, that is what potential energy. So from the ninth class, work energy and power, you might be remember. So potential energy, so this is also for IIT, JEE and as well as for NEET, of course for automatically for NCERT level. So this is one of the most important concept. So you might be studied in class 9th, you might be see the chapter number 4 in the physics, we used to say work and energy chapter. So we might be studied the types of energies and the transformation of energies and many forms of energies. In that, the one of the main important type of energy, which we used to call as what? Everybody? Mechanical energy. So mechanical energy means combination of two energies. One is kinetic energy plus one is what? Everybody. Another one is, please respond, potential energy. So this kinetic energy is possessed by the body when the body is in motion. So when the object is in motion, the energy possessed by the body is called as kinetic energy. Now, potential energy is due to the position. So based upon the position of the object, so it will attain the potential energy. So when we studied in ninth class energy transformation, type what is potential energy, what is kinetic energy and all. Anybody remembered? Everybody? Please respond. And same way you might be studied in ninth class. Types of potential energy, two types. One is elastic potential energy. Elastic potential energy. Another one is gravitational potential energy. So remember, this gravitational potential energy only, simply I can say potential energy. So these are all the things like basic, fundamental. So for example, if a car is traveling in a road, it will possess what energy, everybody? If a car is traveling with a velocity v, so it is motion. So it will possess what energy, everybody? Yes, please. Kinetic energy.
Kinetic energy.
If it is, for example, it has been kept on a, so I kept on a above road, like for example, there is a building. So I placed the car above the building. Now what is the energy? It is above from the ground. So it is possessing what energy, everybody? Potential energy. So potential energy it is possessing. But if you notice, yeah. So this is what we used to, due to the position. So position above from the ground, always it will possess the potential energy. So this is all very basic level. Of course, that ninth class basic is very important. If you are not familiar in that, it is not easy to understand 11th potential energy. So keep in mind, in 11th class potential energy, first thing I'm introducing, the potential energy in 11th class we used to represent with the U. What is the symbol for potential energy? Everybody? U. Okay. Now, for example, so sir, what is the use of this chapter? What is the use of this concept if you want to learn? For example, the given concept is, the given applied force is x square I cap plus y j cap, y j cap. Okay. Now, at this point, suppose for example, they mention potential energy at 0, 1. 0 means x and 1 is what? Everybody? Y point, which is equals to 10 joules. What is the potential energy? Everybody? 0, 1 means what is the energy? 10 joules. Then, if the potential energy at 2, 3 point, how much is the potential energy? If the limit changes from 2 to 3, that is what, from 0 to 1 to 2 to 3, how much? Like this sums we will solve in the class 11th. Now same way for example. So we all know a chain. For example, yes, this is what we used to call as a chain. Please remember, I will use many questions, many concepts like this. So this is what we used to call as what? Chain, basically. The chain which we are wearing. Now if you say for example, so the chain has been kept arranged in such a way that it has been like this. Now, so in these cases, like it is above from the ground, from the point with H. So, and it is having a mass M. So, what is the potential energy possessed by the body? That is what? Total potential energy of the chain. So, this is the potential energy of the, what is the potential energy of the chain? So, like these cases, what we are going to study in our today's class, how to calculate potential energy, when it is, and given applied force is something, at a given point, the potential energy is 10 joules means, then at a new point, what is the potential energy? So like these things we'll discuss in this concept. So first of all, you remember like 9th class, potential energy means possessed by due to position. Potential energy means what, everybody? Potential energy is due to the what, everyone? Is due to the position of the object. Okay, everyone? So now, if any object is placed on the ground, can you tell me what is the potential energy? If any object is placed on the ground, suppose I
Zero,
put
sir.
one object and potential energy, object is on the ground. So what is the potential energy, everybody?
Zero.
Potential energy is equals to 0 joules. Understand now, Rudreswar? If any
Yes, sir.
object is on the ground, the potential energy is 0. So keep it in mind, like 9th, we cannot define like potential energy means it is happening due to the position. So actually, it is impossible to define the potential energy. So basically, we people, it is not possible to define potential energy. Only we can define. It is not defined. It is possible to define not potential energy. We can define what, guys? Everybody? Please respond. Change in potential energy. Understand, Laksha? So it is not possible to define potential energy of a body. What we can define, Pradosh? We can define only change in potential energy. Understanding, everybody? So whatever we are studying is not that we are defining the potential energy. What we are defining, everybody? Change in potential energy. Understanding, Amma? All of you? So, what do you mean by that? Change in potential energy only will represent with a delta U. What will represent, everybody? Change in potential energy represented by what? Delta. So, it is not defined. Keep it in mind, very important point. It is not defined for non-conservative forces. Understand, Sir? Why you said on the ground means frictional force is 0. Sorry, potential force is 0. Because the potential energy is 0. It is not defined for non-conservative forces. What is the example for non-conservative force? Anybody? Speak, Ra. What is the example for non-conservative force? You all people studied already. This is very bad. What is the example for non-conservative force?
Frictional force, sir.
So the change in potential energy is not defined for non-conservative forces. So it is only defined for what, guys? Everybody? It is only designed for conservative forces. Means what is that? Conservative forces.
Gravitational force.
Yeah. Gravitational force, elastic, and as well as next one is what?
Spring.
That is what? Elastic only, spring, Rudresha. Clear? And as well as
Okay, sir.
electrostatic force. So the change in potential energy only possessed by the what forces, everybody? Conservative forces. Be very careful. That is what? So change in potential energy, delta U is equals to minus of. Sir, why is minus? We'll study that. Clear, everyone? All of you? So minus of work done. Minus of work done by what forces, guys? Speak loudly. Work done by conservative forces. So if anybody will ask you potential energy by the potential energy equals to what is that? Work done by non-conservative forces. How much? The potential energy by non-conservative forces. How much, guys?
0.
Yes. Okay. So it is not applicable. Clear, everybody? Understanding? Understand, Amma, everybody? So only potential energy possessed by what? All of you understand? Yes. Okay. So conservative forces is only applicable. Potential energy is only applicable for conservative forces. It's not for non-conservative forces. Understand, Emma? All of you? Yes? Everybody? No. So I'm saying that it is not possible to define potential energy. Only we can define what, guys? Everyone? Change in potential energy. So change in potential energy means what you can say? Anything change means what? Final potential energy.
Final minus initial.
Initial potential energy minus work done by what forces? Work done by
Conservative.
conservative forces. That is what is the potential energy. Write it fast, everyone. Any doubt? Anybody can ask me. Okay, guys?
Yes, sir.
Yeah. Next. So now if you notice it, sir, what is this one? Shall we prove it now? Sir, this is the formula for what, guys? Everybody, you should keep it in mind. What is the formula for this one? Change in
Potential.
potential energy. Sir, how, sir? Let us discuss it. Okay. Now, if you observe very carefully, all of you, so let me consider now there is a ground. If I consider there is a ground, so ground means what is the potential energy? Everybody, speak loudly.
0.
Potential energy. Now, the object which is above from the ground of a height h1. What is the height h1? Everybody, height h1. So having a mass m. Now, it has been shifted to a height h2 from the ground, guys. From the ground, it has been shifted from a height h2 from the ground. This is what it is. Ellame Purima, please speak, everybody. So now, we all knows that just now we studied final kinetic final potential energy minus initial potential energy is equals to minus of what? Everybody? Work done. Okay. Work done by what forces? That is very important. Work.
Conservative.
Yes, please. Work done by?
Conservative.
Conservative.
Yes. Okay. So that is what you have to remember. So now observe very carefully at this position. What is the potential energy possessed by the body? Let me take this is the initial one. So that is the initial one. What is the potential energy possessed by that one? mg.
MgH1.
Put in mind, potential energy formula is mgh. Potential energy formula is what? Everybody? Generally, potential energy formula is mg. Now, at this place, what is it? This is initial potential energy. What is the final potential energy at this place?
MgH2.
mgh2. That's all it is. Then you can do it. So, what will happen? uf minus ui, which is equals to, as we know. So, what is that? Substitute it. mgh2, final minus initial. mgh2 minus mgh1, which is equals to mg is common, h2 minus h2 minus
H1.
h2 minus h1. So that is what it is. So this is only is equals to what? Work done by what forces?
Conservative forces.
Conservative.
Conservative.
But observe very carefully. As the body displacement showing upward direction or downward direction? Displacement of the bodies. Pradosh, can you able to understand?
Upward.
Upward direction. Displacement is upward direction, but gravity is acting downward direction. Means what is the angle between them? Speak loudly.
180.
So cos
180.
180. Cos 180
Minus.
is how much? Everybody, Aswita, minus 1. So that this whole term will become what? Everybody. So final kinetic energy, sorry, potential energy minus initial kinetic energy equals to minus of, speak, h2 minus h1. Sir, how sir this one? So can you tell me what is the work done? Everybody check it here. So height changes. This is what the height changes. How much the height changes? All of you check it. What is the height changes?
H2 minus H1.
h2 minus h1. That's all. And what is the weight of the object? Weight of the object is acting what direction? What is the weight of the object?
Downward direction.
mg. So that's all. So that's what it is. Force into displacement. That is only work done. Am I right or wrong? Work done is
Yes,
equal
sir.
to force into displacement. So applied
Yes.
force is mg and displacement is h2 minus h1. But both are 180 angles. So that cos 180 is how much? Speak loudly.
Minus 1.
Minus 1. So that is how the change in potential energy is equals to minus of work done by what forces, everybody? Work done by
Conservative.
conservative forces. I hope you all understand. Anybody having any doubt, please let me know. Understand, guys? Everybody? Yes? So let's consider extremely small changes. Small changes means immediately you have to use some mathematical one. Very small changes of
Difference.
energy by small change of conservative forces. So that what will happen? Speak loudly. So
Difference.
delta U become what? Delta U become du.
D.
W work done become what? dw.
DU.
Right or wrong? That's what. Now, This is what for small work done, very small. If I want to find total work done, anybody can tell? Suppose I want to find total, then what I should do? Again, mathematical tool. Sikrama Pakranga. What is that? Integration.
Integration.
So du
Integration.
is equals to minus of d into omega c. That's what, sorry, work done by conservative forces. So can you tell me from this, what is the work done formula? Anybody of you can tell. Work done is equals to what? Work done is equals to force into what? Respond. Work done is equals to what? Force into displacement. So here displacement only very small. So that what will happen formula? F dot dx. Am I right, Rudreswa? Very small displacement. Prima, small displacement means we will consider as a dx only. Correct or not? We studied or not? Already.
Yes, sir.
Suppose if this is the length, so in this particularly small part means we will consider as a dx only. Am I right or wrong, guys? All of you? Speak loudly. But so work done is equals to what is the formula? Integration of f dx. Okay. So I will replace it here. So integration of du. This is du, guys. What are the limits, guys? Tell me. What are the limits? Initial potential energy to final potential energy. Okay, wow. Understand, my girls? Speak loudly. So initial
sir.
potential energy to final potential energy. So this is U and this is also U, which is equals to here minus of in place of work done. What I can write, everybody? In place of work done, F dot.
FD.
But this C is a what? Conservative force or non-conservative force? Conservative force. So this is also I can say same thing. That is what? The work done by the body. So how we can find? This is how we can. Is it okay, everybody? This is also the formula for potential energy. Understand, Rudeswa, Pradosh? This is also called as formula for what? Potential energy. Okay. Clear, everybody? Any doubt, please let me know. All of you understand, Amma? Aswita? Okay. So this is how we people will make what is potential energy. I hope you all understand what is potential energy formula now. So this FC, what do you mean by FC? Speak loudly, everybody. The force applied by what type of forces? It is a
Conservative force.
conservative forces. So this is also the formula for potential energy. Okay, guys. So any doubt till here, you can ask me. Everybody clear? Please respond.
Yes, sir. Yes.
So let us take question number 1. All of you make. For example, conservative force is 2x. So 2x it is saying. So it is a fixed one or variable force? Everybody. It is the variable.
Variable.
Force. Understanding or not? So U at x is equals to 1 is 10 joules. U at x is equals to 1 is equals to how many joules, everybody? 10 joules. The question is now, find U at x is equals to 2. That is the question. So let me see how you people will solve. So very simple. So U means what? You should not take U. U means what I have to tell you. Already I told you. What you should take? U means change in potential energy. Understanding, all of you? Change in potential energy. Final potential energy minus initial potential energy, which is equals to what is the formula? Minus, speak loudly, work done. Understanding? So what is the final limit? 2. Initial limit is 1. So final potential energy minus initial potential energy, which is equals to minus of, what is the limit? What is the W? Just now we have done. What is that W means? Force.
Yeah.
Means force exerted by
Force into dx.
and what is the limits? Check it, everybody. Limits. Limits how much? 1 to
1 to 2.
speed 1 to 2. That's all. Now we all knows that initial potential energy. What is the initial potential energy? They have given already. Have given x is equals to 1 means what is the initial potential energy? Everybody, check it. X is equals to 1 means what is the initial potential energy given already? Yes,
10 joule.
10 joules. So which is equals to. So what is the FC value? Everybody speak loudly and tell me. So minus of integration of 1 to 2. So FC value how much? Observe applied force. Pakrang here. What is this? You people observe it. 2 or 2x?
2.
2x into dx.
4x, sir.
Now, so this 2 is constant, I will put it outside. Integration of x. Integration of x, so what is the formula? Anybody? Integration of x, mathematics. X
X
square
square by
by 2. Please,
X square by 2.
what is the formula? X power n plus 1 divided by n plus 1. That is the formula. Am I right? Others? That's fine.
Yes, sir.
So, integration of x. What is the formula? Integration of x. X square by 2. Understanding? Limits 1 to 2. Am I right or wrong? Others? Speak.
Yes, sir.
Yes, that is
Yes.
what. So now, if you substitute, what will happen, everybody? What is the values? You all should find it. So final potential energy is equals to minus 2 into this one, it will come here. So 2 square by, sorry, this 2 can I get cancel or not? I'm just for small, just
Yes.
make it more complicated. So 2 will get cancelled, minus of this x square. So minus of x square means what? 2 square minus 1 square. So which is equals to minus of 4 minus 1. So which is equals to what is the answer? Speak loudly. Minus 3. So which is equals to minus final potential energy minus initial potential energy. So final potential energy is equals to minus 3. This plus 10 will come this side. What will become? Sorry, minus 10 will come this side. Will become what? Plus 10. So
Plus
what is the
10.
final kinetic energy? Everybody? Plus 7.
7.
Plus 7 joules. Understanding? Smita, Manu and Samaya, anything doubt, please ask me. So this is how you have to solve it. Any doubt, guys? Mr. Narayan, understand, Princey? All of you? Solve it.
Yes, sir.
Those who understand, Nara?
Yes, sir.
Yeah, please proceed. Make it quick, everybody. Anybody having any doubt, please kindly let me know. Prima, எல்லாமே completed?
Yes.
Yeah. Okay. So let's start next question, everybody. If you are interested, we will proceed. So let's start. This question completed, Aswita. I'm asking, but no response. Understood? Okay. The given question is f is equals to 3i cap plus 4j cap. 3i cap plus 4j cap. The given limits for initial potential energy is 10 joules. And the given limits for final potential energy is how much? So that's what it is. So what are the limits for final potential energy? Check it, everybody. 2 comma. 2 comma. Respond ra 3. Okay, va? So that is what. Now it is notice x and y, and this is also, let me take x and y. Now all of you observe very carefully limits. So what is the work done is equals to formula. Speak loudly. Final potential energy minus initial potential energy equals
Initial
to
potential.
minus of work done. Okay, va? So final potential energy minus of, what is the initial potential energy? Pakranga. Initial potential energy 10 equals to minus of. Now what is the work done? Speak loudly. Work done is equals to what? Rend axis. One is x direction, another one is what, Ra? Speak loudly. Another one is y direction. Okay, va? So if z is there, then z also will come. So how it will be? Pakranga, everybody. So it will comes like this. So integration of x pakranga, x 0 to how much limits? X mattuda 0 to 2. Okay.
2.
Fx dx. Fx dx plus next integration of y, you can tell it. Y how much? 1 to respond all limits 1 to 3.
1, 2,
That is what? Fy dy. See, 2 times I am doing integration. Do you understand why, guys? Anybody can tell? Because force is in how many directions? Force is in
2 direction.
two directions. X and as well as y. For example, if I put here z, then what will happen? For example, here I will add one more column. Next question will come. For example, I will put it 2. Then what is the next column will come here? Integration of, suppose here 1. So integration of 1 to 2. Okay, sorry. This is final. So this is 2 and this is 1. So integration of 1 to 2. And what is the formula will come here? Speak loudly. Everybody. If it is third is there means, what will happen, guys? Fz dz. Am I right or wrong? Speak loudly. Understand, Emma? That is what. So it is just for example I am saying. If it is z axis there, then do the integration. Ellame puriyam. So fx. So integration of minus of integration of 0. Fx value how much pakranga? Fx value. Fx means direction, applied force in x direction. How much, guys? Inga paakranga. Ellame simplicity. How much it is? Yes, please. 3 dx plus integration of 1 to 3. Fy value paakranga. Fy value how much? Inga paakranga, everybody. See here. How much it is? 4.
4.
Fy is equals to 4 into dy. Am I right or wrong? Do you understand, brothers, now why I am doing 2 times of integration? Clear?
Yes, sir.
Yeah. So that is what. Prima, all of you understand, Amma? Yes. Suppose if it is z is there, z also you have to do integration. That's all. Integration of 4 dy. So everybody do it now. How integration of 3 is remains constant. So or else you can do it. You try, you can. So what will happen? 3. So 3 is remains
Taking
constant.
out.
I'll put it outside. So here what will happen? Integration of dx. Integration of dx.
X, sir.
X. Okay. X limits is 0 to 2 plus this one. 4 is outside, integration of dy.
Y.
Y. So
Y.
limits is 1 to 3. Okay, wow. Lama understood? Speak loudly, that's all. So
Yes, sir.
minus of this is final velocity minus 10. So 3 into this one 2 minus 0 plus this one 4 into 3 minus 1. So what will happen, everybody? Ultimately this one minus of 3 2s are how much? 3
Six,
into
sir.
2 are 3 2s are 6 plus this one 4 into 3 minus 1. 3 minus 1 is how much?
8.
3 minus 1 is 2. So 4 2s are 8. So it will turns into 6 plus 8. Am I right, guys? All of you? So 6
Yes,
plus,
sir.
this is minus. So minus sign means what? 6 plus 4, 18.
Minus 14.
18. So minus 14, UF minus 10. UF minus 10. Okay, then minus 10 will come this side. What will happen, everybody? So final kinetic energy, which is equals to minus 4 plus 10. Equals how much?
Minus 4.
-4.
Minus 4. Okay. So minus 4 joules. That is what it is. Final. Okay. Final kinetic energy. Anybody having it? Sorry, final potential energy. Anybody having any doubt? You can ask. Everybody clear?
Yes, sir.
Yes. That's what it is. So it's very simple. Clear, everybody? Understand, all of you? So
Yes, sir.
final potential energy minus 4 joules. Okay. So let us solve one more question for the class. Then we will prepare for your exam for tomorrow's. So there is a question now. You solve it. If you're not understanding, then I will say you. But everybody has to try. X square I cap plus yj cap plus z square k cap. Understanding? So the given function 0, 1, 1, which is equals to 10 joules. Second one is 2, 3, 2. Then what is the new potential energy? Other formula. So what is the formula we'll use? Final potential energy minus initial potential energy, which is equals to minus of work done. So work done is equals to, what is the formula? Work done is equals to, please speak. Work done is equals to, what is the formula?
F dx.
Force into distance. So work done, if I take work done, so what will happen? It may be, all of you respond, what is happening here? So if I take this one, so actually what is the F into S? So what is the formula we have written for work done? Everybody. Work done is
F dot.
F dot, yes, that is what we have modified. What is that? F dot dx, total distance.
Yes,
very
sir.
small, extremely small, so that work done is equals to F dot dx. So I will write in place of work done, what I can write? F dot
dx.
dx. But observe very carefully, Pradosh. This is only for x-axis. Then what about y and z-axis? So totally 3
F dot dy.
x, y, z. X, y, z. What are the limits for x? Everybody check it. Limits for x is 0, 2. Next one, again integration of, yes please, y to do that. So what is that value? 3 and 1. So what we can do? 1 and 1 and
3.
3. And here what will happen? Fy dot dy. Am I right or wrong? Here I forgot it. Fx dot dx. Next, if it is last one, suppose if it is you can take it your choice. So z direction. So what are the limits here? Z direction 1 to, speak loudly, 1 to
1 to 2.
So it will come how much? FZ dz. Am I right or wrong? Everybody clear? Speak loudly.
Sir.
Mr. Narayan, understand, Rohit? So that's all it is. Then UF minus 10. This is remember this. Already we have proved it. UF is equals to how many joules? All of you? Minus 4 joules. But how many actions it is acting? 2 directions or 3 directions or force? Everybody. Only, I already told to even now also. So here if you take only force is acting, how many directions? Everybody, only 2 directions. Understanding, Amma?
2 directions.
Please respond. But here, if it comes to here, this force is acting how many directions? This is here only 2 directions, I and Y. Sorry, I and J means x-axis and y-axis. Now here 3. So x, y, z. So that it will goes x-axis, y-axis as well as z. So what is the final kinetic energy? That is what is the question. So let's start now, everybody. So initial kinetic energy, what is the initial kinetic energy value? Speak loudly. 10.
10 joule.
Okay, ma? So now final kinetic energy we want it. So how to make it, everybody listen. So very simple. So fx value solunga. See the equation and tell me fx value.
X square.
X square I cap plus y j cap plus z square k cap. Am I right or wrong? Where this is what
Yes,
the
sir.
yes. Others also you have to involve. So that now x square value solunga, everybody. 0 to how much ra? 0 to 2. X
Two.
square dx plus next one fy value how much?
Y.
Everybody, and limits check it.
Y
dy.
dy.
Okay, plus last one 1 to 2. What is that? Fz into yes please.
Sir, Z square.
Yes, fz. Sorry, here z square. Sorry with this. Thank you. So this is not fz. That fz already replaced. Gone. We are replacing with what? Everybody. Z square. Okay, Vara? Everybody ready? Yeah?
Sir.
Yes, that's what. So then we all knows that integration of x square. You people know or
X
don't?
is cube by 3.
Yeah, x cube by 3. That's what it is. So that n power n formula, remember, everybody? Speak, respond,
Yes,
guys.
sir.
N power formula. That's what it is. So minus of. So now you tell me x square. What is that? Valency. Fastly integration apply and tell me like how we will do
2.
calculate the valence and madri. So x square means what? X square 2 plus 1 by 2 plus 1. How much it is? Yes, please. X cube
X
divided
cube by
by
3.
3.
Divided by
0 to 2 plus. Here, integration of y dy. What is the formula? Integration of
Y square by 2.
yes.
Y square by 2.
So y square by 2 means, can I write here, Rudreswa? This is y square by 2, limits is 1 to 3. Am I right or wrong? Yes.
Yes, sir.
Next one, limits check it, everybody. Integration of 2 to 1 now, 1 to 2 to 1 to 2. Okay.
1 to 2.
Integration of 1 to 2. And z value how much it is? Z square. Z square means how much?
Z cube by 3.
Z cube by
Z
3.
cube by
Please write it. Z cube by 3. Clear? Understood, Amma? Everybody? So limits, you forgot it, limits here. So limits is equals to 1 to 3. I'll erase this. So please proceed it now. So what else is there? So only substitution. So that's all it is. If you substitute it, how much answer will come? Let me see who will say first. I'm giving 5 minutes time. Oh, Naren already solved. Naren, how much answer? Solunga, everybody. So yeah, final velocity, final potential energy minus initial potential is equals to minus of this one. How it will come? Speak loudly, everybody. Yes, in place of x, I will substitute 2. 2 cube minus. Okay, 0 means 0 only. So you can take here 3. Okay, by 2 cube by 3. So minus this. If you want, you can put it 0 cube by 3. Okay, wow. Next plus this one. So 3 square by 2. Okay, minus 1 square by 2. Am I writing correct? Everybody has to involve. Plus next one. Okay, what is the next one? X, Y, Z. So what is that, everybody? Speak loudly. So Z cube means what? Z power, already Z cube, guys. So what is that? Sorry, Z cube, what is that? 2 power, sorry.
2 cube.
Yeah. So what will happen? Z cube means?
Sir. 2 cube by 3 minus 1 cube by 3.
2 cube by 3 minus 1 cube by 3. Am I right? Speak loudly.
Yes, sir.
That's all. So UF minus 10. Already Narayan solved. Very good, Narayan. So minus of 2 square. This is fully same. So minus of 3. Okay. Next minus 0 plus this one. 9 square by 2. How much, Amma? 9 square by 2. Okay. So that is also how to do it. 9 square by 2 minus 1 square means 1. 1 divided by 2. Am I right, everybody? Please respond. Yes? All of you? Then here you can substitute. So 2 cube. What is the 2 cube value?
Sir,
2 cube value.
9 by 4.
Sir, 9 by 2, sir.
2, sir.
Oh, sorry. 9 by 2. Okay, then you tell me this one. 2 cube means how much, Ra? 8. Am I right or wrong?
Yes, sir. 8 by 3.
Minus 1 divided by
1 by 3.
So that's all it is. Now you solve it, everybody. So this I will take it as a minus 3. This one, Enda Pradosh?
Sir, 2 cube divided by 3, how sir? Minus 6 by
2 cube, correct? Oh, 2 cube means it is 8. Am I right?
sir.
Yeah.
Yes, sir.
Yeah, 8. Very good, Amma. Sorry, 8.
Plus 8, sir.
Sir, minus also will not count.
Oh,
Plus
this
8.
very good. Okay. So plus 8. Now tell me this one. LCM is 2. Remaining both are correct.
Yes,
Yes.
sir.
9 minus 1 is 8. Next plus this one. This one is how much? Check it, everybody. 8, 3 is
7
LCM.
by 3.
7 by 3. So now solve it, everybody. Everyone take it and do it and tell me what is the answer. So minus of this minus means somewhere we are doing mistake. Check it. Narayan, where is the mistake? He has got the answer. I think y square 3 correct. We have forgot the limits. Am I right? Check it, everybody. What is the mistake we committed, Mr. Narayan? Somewhere I have committed the mistake. Okay. So let us see that. So what is that, everyone? Take the LCM. Can I take the LCM as a 6? Clear?
Yes, sir.
Take the LCM as a 6. Then here, how much it will come?